Hello everybody, how you doing? Sorry for the late start. It's just one of those mornings. Okay, so we're going to crack on today. We're going to look at Python again, funnily enough, but today's is going to be particularly helpful. We're going to be looking at exception handling, and this is going to be really, really helpful. Like I said, let's just crack on and let's get to it. So open up your favourite IDE. And we'll get to starting. I'm just going to check that it's working. It is. So there's a bit of a delay. There's a bit of a delay with the live stream from when I actually start speaking. So, oh, come on, catch up. There's quite a lot of delay today. Let me just check. Right, there we go. Right, sorry about that. Okay, right, we're there. There's quite a lot of delay today. Stupid YouTube is doing my head in today. There we go. Right, we start. And we go. Okay, so yeah, today we're going to be looking at exception handling, and this is really going to elevate your code. And it is something that I really wish I could cover in the GCSEs that I teach. But it's just, we just haven't got time really. So yeah, exception handling. And this is a really good skill to have. And again, yet again, not only does Python have exception handling, but other interpreted languages, which if you know about the way that different languages turn their code into binary, Python is an interpreted language. So is Java, and Java works almost identically, or just slightly different, but the principles are the same. So let's just create some code. And the first thing that we're going to do is we're going to just create an input here, and we're going to put an int input. So do copy this code if you want to. Enter your age, because obviously you can keep the code and refer back to it. So just a straightforward input. Age equals int input, enter your age. So obviously we can print that age out, and we can say print the age. So if I run this, I've got enter your age, and I can enter something like this, and it just prints it out. Perfect. Now that's all very well, but as you can see, we've got an int here, and this int turns the user input into an integer variable, which is what we would normally need for an age. But it does mean that if I don't enter an integer, when I enter the age, I'm going to get a horrible red error. That's what I'm trying to say, error. So let's try that. I'm going to force it to have an error, and I'm just going to put hello. And you can see there I've got horrible red error. Value error. Invalid literal for int with base 10 hello on line 2 of main.py. So what that is actually telling me is, it says because it's a value error, I've entered the wrong data type basically. So when push comes to shove, the error is actually telling me I've entered text instead of a number. Now this is a really common problem that you will get with users entering data. You want a number, but they enter text, or you want text and they enter a number. Or you want a whole number, an integer, and they enter, a float or a real number with a decimal place. So there is a really good way to handle this, and it's exception handling, which is what we're looking at today. So the way that we do our exception handling, we can handle this really nicely. So if the user enters something that is the wrong data type, we'll actually say no nicely, instead of just if this ran on a server, this value error, it would just kill the whole program, and we don't want that, because this nobody wants a horrible error just stopping your code. Okay, so what we do is we put an exception block around it. So to handle this error, sorry about the tippy tappy again, I can't Still can't get my Bluetooth keyboard working again. So to handle this error, we use a try catch or try except. I'm still in Java world. In Java it's try catch. In Python it's try except. So all we do is we put try, the word try, and then a colon. And what that means is anything inside that try could potentially cause an error. That's fine though, because we're going to handle it. So we would say, put our code here. So I'm just going to copy it, and you can see it's indented. It must be indented. The try is just like an if or a for or a while. We've got to indent it for that to be underneath. So we're going to try running that code. That's basically what it means. We're going to try running that code. And we can print their age as well. You know, that's fine. But what happens if they enter hello instead? Well, this is what we do. We capture that error in the except. So the next keyword here, we put except. And we would put print. That's not a valid number. And that is literally it, basically. Now, there is more to it, though, because you can be a little bit cleverer. But let's run this. So, first of all, I'm just going to, for that first one without the try block, I'm just going to comment it out so that we can just run the try except. And if I run this and I enter my age, it should work perfectly. Yes, that works fine. But now I'm going to enter hello again. And instead of that horrible red error, which would kill your program, actually what happens is it says it's not a valid number. I.e., we've got an error here. It tries to run that code. And if there is an error, it will go to the exception block and it will do whatever you tell it to in this exception block. So try running that code now and just seeing what happens, and just let me know that it works okay. And someone said in the chat, Isaac Computer Science Booster Sessions, yeah, they're really good. I highly recommend them. Free by the UK government. Sign up, nothing to pay. Yeah, I recommend it. Definitely. It's all part of the National Computing Centre type government thing. Yeah, Isaac Computing has got their own website with stuff on it as well. I don't think they've got the iGCSE for Cambridge, but very helpful. Has that run okay, everybody? Now, what you can do is, and what I used to do when I was a Java programmer, is I used to put all my code in a try. So normally I would have just my whole file with lots, like 1,000 lines of code, and then I just have a big try at the top. And yeah, it's really, really helpful to put this in. You can be more granular, whereby you just put it in certain bits of code where you know you're going to get an error. What we can do though is we can so this except block here, it will capture any error, but sometimes you want to handle different errors differently. So let's just have a look at doing that. So this time what we're going to do is we're going to specifically capture one error. So we're going to do another try, and I'm just going to show you. We could do the same thing actually. We'll just do age equals int input. Enter your age. So do the same thing. But this time we're going to put an except, but we're going to put except and then the specific error that we want to capture. And we saw earlier that that specific error, it was a value error. So we can say except value error, print that is not a number. So we're saying if there's any other problems, just ignore it. But if it's specifically a value error, then that's what you're going to put here. We'll look at some other errors that you could get in a minute, because there's lots that you can do. So again, if it's going to run this twice, so that's fine. If I put in hello, that's not a number. It's running it twice because it's running this first and then it's running this one as well. But it's specifically caught a value error, i.e. you've put the wrong type in. And you can have as many of these as you like, because what you can do is you can also put just except, and that will capture anything else. So this captures any other error. There's probably not going to be any other error, but you never know. In this block anyway. And you can have layers of them. So you can have except value error, except index error, except name error, except whatever. It doesn't matter. You can have as many as you want to capture and handle them differently. So it's a very powerful mechanism to make sure that if you have these problems in your code, they're handled nicely. Let's look at one where we're opening a file. So this is a very common error. I'll just pause there just for one more minute, let you catch up in case, if not, you can always watch the replay. And then we're going to look at handling file errors. So, good. All right, so let's have a look at another way of handling an error. And this is file handling, text files, whatever file, it doesn't matter. Absolutely always lots of problems with file handling. So we can capture errors with file handling. So we do our try. And this time we're going to try and open a file. So we do file equals open data.txt, and we're just going to read from it like that. I don't think you can send links in the chat, so you'll have to so for Isaac, it's just if you search for Isaac computer science, it'll come up in the Google results, and then on that you look at I think it's like live sessions or something like that. Can't remember. It's on there somewhere. But. Okay, so then we're going to try and open our file to read it, and then we're going to get the content from the file. So we do file.read, open close brackets. And then we can just print out the content. We're not worried too much about what's in there. We're just showing what you can do. So opening a file to read is fraught with all sorts of problems because that file might not be there. So we can handle that though. So actually what I could do here is I'm just going to very quickly, don't do this, just watch for a moment. I'm just going to just try and open the file. I know for a fact that the file is not there, okay? So I'm just going to show you the error. Oh, I've got indentation error. line 30. Oh, I need a, sorry. Oop. So this last line here, I just need a line of code. It doesn't like it. Like, you know, Python, any block of code, for, if, while, a try, or an except like this, you must have at least one line of code. And if you don't have that, then Python doesn't like it, gives you an error. So I just put pass, doesn't do anything, just literally says do nothing. So if you have that error, just add pass. And then I've run this code here and you can see that I've got a file not found error. So nightmare, it's killed my program. So if you imagine someone's using your software and the file that you're going to upload isn't there, and uploading files is very common in, you know, especially in this data age. Well, this is no good. We can't let this just be in our code like this, so we can have a try and except. So we add our try. We're going to try opening the file and we're going to indent that underneath, and then we're going to handle that exception, and we can do it explicitly with an except for that error, and it's a file not found error. So what you can do is if you're running your code and you get an error like this and you're like, oh no, I wasn't expecting that, look and see what the error is, copy it and put it in an except. So I've just literally copied that file not found error, put a colon, and then I'll just put print, sorry, that file, it does, or sorry, can't find that file. So instead of a horrible error that's going to kill our program, it actually handles it nicely. So we can see here, sorry, can't find that file. So this is a really, really important one if you're doing anything with file handling. So just test that and see that it works. Yours works, fantastic, good. This is a quirk of languages that are interpreted. So if you're using a language that is compiled, like C++, for example, you don't have to do anything like this because it will force you to handle it in other ways. But this is specific to languages that are interpreted like Python and Java. Okay, so let's look at another example. Or actually, we can just put here except print any other error is captured here. So another example might be, what are we doing? Because you didn't know what we were only supposed to watch. No, it's always the case with this that Oh, I see what you mean. Yeah, so I just very temporarily showed you the error if the file is not found. And the file isn't there, so just make sure you've got this code here. So all I meant was don't, with this bit here, where we're trying to open the file without a try catch. Oh, my sound's gone off. There we go. Just let me know if you can't hear me. So if I run that again, it's a bit slow. Come on. I don't know what it's doing today. Let's try that again. Run, file not found. So it doesn't even get to this here. It kills the whole program. So that's what I meant. I'll just delete that. Now, if you go to the sort of the official Python documentation, there is a list of all the different exception errors that you can capture. But yeah, you can just look it up. But like I said, most of the time you'll get these errors and you're like, oh, I wasn't expecting that. So just put it in a try and accept. Let's look at another example. This one is a divide by zero. So actually, let's show the error first. So this is a divide by zero error. And you might know or might not know about divide by zero. Computers can't divide by zero. It causes them a massive error because if you think about it, you can't actually in real life divide by zero. So if you've got, 4 divided by 0, well, it's pointless because you're not dividing it by anything. So you might as well just not bother. But with computers, they really don't like it. So, if you've ever done any kind of maths calculation things, I know if you have with me in my classes, we've done some calculator programs, etc. Well, you could potentially divide by 0 if they're doing division. So let's try that. Let's try result equals 5 divided by 0. Okay, so I'm just going to hard code that value rather than use variables. So if I run this, got another error. Division by 0, all in on 5, 0 division error. So although computers really don't like divide by 0, they check for it. So how do we handle this? Well, we're like, oh, okay, I've got a 0 division error here. What am I going to do? So what I want you to do, your task, is to write a try catch, sorry, try except, so I'm still in Java land. Write a try except to handle the divide by 0 error. Divide by 0 error. It's too helpful trying to put that on. Okay, so that is your task. I'm going to go quiet for a few minutes while you write that, and you can just put this in it, that's fine. You don't have to use variables. If you want to use variables, the user inputs, that's fine, but you can just use that line number 5. The main thing is that you understand the concept. Yeah, so someone's asked, will this be similar to the file one? Yes, except you're just getting the zero division error captured instead of the file not found error. Okay, let's have a look at the answer to this then. So all we're going to do is we're going to try, and we're going to try to divide by 0. And then we're going to capture that. So we say except, and then we're just going to copy that error, 0 division error, paste it in, and then we're just going to put print, you can't divide by 0. So obviously this could be capturing a user inputting what they're dividing by. We'll just stick with this here. Now I just need to comment out this line here. If I don't, then it will just get the divide by 0 error. So if I run that, you see there it says you can't divide by 0, and it just carries on with the next line of code instead of crashing out your program. So really clever way of handling these errors. And like I said, sometimes you might not be expecting these when you're testing things and you're like, this is a bit weird, wasn't expecting that. Just add it in a try and except, and then it should handle it nicely. So that's the error to that one. I mean, like I said, there's lots of different errors that you can capture, but if you're not sure, just put one except without anything specific and it will carry on. Now, one of the really clever things about try except is that you can actually raise exceptions as well. So although this captures an unexpected error, like the 0 division or file not found, etc., you can actually raise an exception and say, actually, that if someone does this or if this happens, I'm going to force it to have or to act like one of these errors has happened. So it's called raising an exception. Really, really clever again, and it can really elevate your code. So we're going to raise an exception. And obviously the sort of the code that I'm going to write is quite convoluted because I'm forcing it, I'm sort of giving you an example code for it. But yeah, it's a nice sort of little example. So what we can do is we can say, let's say user input equals input, enter some text. So we're just going to get the user to enter some text. We're not using integer this time. We're going to try and get them to enter a string. Yours says the division error, it just says expected and accept on line 11. So just check that you've got yours exactly the same as mine. Just double check it. Make sure you spell everything right and everything is indented the same. And also remember to comment out anything that might raise the error. Okay, so we've got the user to enter some text. We want to make sure that they do enter text and nothing else. So what we can do is we can have an if statement, and we can say if not type user input is string or str. So basically this says if it's not a string, if they don't enter, actually, sorry, I'm just going to change this slightly. Just going to change this slightly. Sorry, just ignore that. Because I don't think that's a very good example. Let's put user input equals hello. So I'm just going to do this even easier. User input equals hello. If not type user input is int, so we want them to enter an integer, basically. We're going to raise an error. I'll just pause there for a moment. I think this is a better example. So we're going to raise an error, raise a type error, only integers allowed. You've copied it all down, excellent. I'm just waiting for it to finish. Come on, it's really struggling today. I know it's really, I think they need to work on this a bit more. I want my money back. So you can see here, if we run this code and it's at the top, it's raised a type error. Now we haven't captured that error. So it has raised an error and it's killed the program, but we could capture it as well. So what we do is we put here, put everything around the try. So we add in a try and then except type error print you or only integers allowed. Like that. So you still need to capture it and still need to have a try catch around it. So previously it did raise the error, but we weren't capturing it. So this time it captures it nicely. We're trying it and we're raising that error ourselves. This is a really powerful stuff. I remember doing this. I used to write software for share trading and we used to use raising errors all the time if things went wrong when people were buying and selling their shares. There's not much I can remember about that code, but I can remember that. Now there is lots more that we could do with exception handling, but I don't want to give you too much. Just know that if you have any kind of user input, having a try and except around that user input is pretty handy to have, especially if, for example, you're trying to get an integer from them, etc. You can raise that error in your code to sort of make sure that that's handled. How long have we got left? 5 minutes. So we've got just enough time just to have a very quick look if my if we can just have a look. I'm just trying to load up my code examples that I had and it's really slow. I've got the world's slowest iPad. Yeah, so I just want to show you a couple of other things. You can also have a finally. So finally basically means you've tried something, there's no exceptions. Finally, we're going to put something in here. So we can put a print here, this code always runs. So it could be that you need to close a file or you need to say goodbye to the person who's using your code. That is what that finally is for. Could you put try and accept inside a function? Yes, absolutely. Yeah, this can be used anywhere and is particularly helpful in functions actually. Yeah, we haven't done functions yet in this series, but we will be very shortly. Next week's half term, but the week after I thought we'd do some loop work and then move on to functions after that. So maybe in about a month's time. Okay, so I hope you found that helpful. Like I said, there's more to try except, but this is a really good kind of overview of the basics of what you can do. I mean, it's not massively more complicated, but so don't think, oh, you know, it's just a small amount. But you're, like I said, if you get those unexpected errors and you're like, oh, I've typed in something incorrectly, then yeah, it will be able to handle that. Like while and for loops, yeah, we'll probably do for loops next time. So in 2 weeks' time, we'll do for loops, then we'll do while, and look at some of the clever things that you can do for loops beyond the basics, really. I mean, there's not a massive amount, but yeah. All right, see you next week, everybody, and have a good week. Might see some of you tonight at the revision, and possibly your lessons as well. Take care.